Hey guys, this is Eric Wanger with Wanger Racing. I'm tying this to the front of the video you're about to watch, which is about the Cloverleaf stuff. And the reason why I'm doing this is because I had made an appeal for Richard Holdner to get a hold of me. We could try to do a test. Well, he did. He reached out. We got to touch each other, and I can't say it's going to happen, but we're trying to work out some of the bugs to see if we can't do a test. We could share with you guys about what would happen if the Cloverleaf was removed. The idea for me was I want to fully port one, but leave the cloverleaf in, and then remove the cloverleaf and port it. This way you'd be able to see a difference that way, because I think just taking it out, you're obviously porting it, so it's going to make a change. So I'd rather see one fully ported with the cloverleaf in or without. Anyway, his thing is he needs to find a suitable short block to do it, because we need one that makes, probably 600 horsepower or more, just because of, well, it wouldn't make sense to put on something that makes 500 horsepower, because the intake won't be a limitation really so much per se in that deal. So you're not going to see a huge change. So we want something that kind of would. So anyway, that's what we're doing with. But we did reach out. He's a super great guy. And that's kind of the progress of that. Typically on Wednesday, I do a little product review video. And I was going to do one over this intake. Hopefully the camera captures it. But I didn't get it done. You'll see it in this. But we'll have to... you'll see me talking about it before I got to this point and talking about the cloverleaf and stuff in this. But I'm sorry I couldn't do a product review on the CHI ported one. I didn't have time to get it done. So I've got more grinding to get done. That's why I'm in the porting room. So you guys enjoy the video and take care. Hey guys, this is Eric Weingartner with Weingartner Racing. Today's video is about the cloverleaf that's in the manifolds and why they're there, and the reason why I remove them or keep them in. Now, hopefully you might have seen me reach out to Richard Holdner in a video to try to get him to see if he'll do a back-to-back test with cutting them out versus not cutting them out. But I told you I'd like to give you my opinion on the matter, so that's what this video is about. I'm going to go over why I cut out the cloverleaf, why do I think it's in there, and the purposes for it. Now, let's get started. Most manifolds that are 4500, which means a Dominator top, have this cloverleaf. It's pretty rare to see it in a 4150 style, although some do. But most 4500 manifolds, Dominator top ones, whether it be a Ford, which is this is CHI, whether it be a Ford, Chevy, or whatnot, usually have this cloverleaf in it. And the question I get asked is, why do you remove them, or why they're there? So I'm going to do my best to try to explain it, why it's there and how it works and what I think happens, and to make sure you'll get a better understanding of what's going on. So in general, the cloverleaf typically helps out, in my opinion, at the low speed ends. So say for instance, if you're trying to make a street engine, like a true street engine, like you're trying at a smaller cubic inch engine and maybe you're only going to 6,000, 6,500 RPM, the cloverleaf staying in might be a good idea. And let me explain why I think that. The way I think that this helps it out is a couple reasons. It makes it more efficient. You're taking up dead areas in the plenum itself at low speeds with this cloverleaf being in place. Over each one of these clovers, I guess you could say, there's a barrel of a carburetor, and the barrel opens and air flows through. Now, I'm trying to give this as an analogy to kind of help you guys out. If you take a garden hose and you open up the faucet so that the water just barely comes out, and just open it where it's just streaming out, usually when it's at very low water speed or exit speeds, the water is pretty much staying, and it would follow this path. You think like the air would follow this path this way too. That would be like low speed engine RPM speed or smaller cubic inch engines. There's not a lot of air speed coming down, so the air will take this path, hold on to the wall, and go right through the runners where it should be. However, if you were to crank up that water outlet out of the faucet and crank it up really higher speed, what you'll notice, like if you look at your faucet hose coming out, the water will actually start to fan, like it will spread out. Well, the same thing should be happening in the carburetor. The air wants to spread out. Well, then you've got this being restriction to you as that's happening. That's one thing I think is happening. So as the barrels get a higher engine RPM speed or more air draw because of the engine being bigger, the air coming out of the carburetor wants to spread out to the areas. And this now becomes the restriction. The other way to think of it, besides just being a garden hose, you can think of it like an air compressor. If you have an air line that's pulling from the air compressor and it's pulling a bunch, if you have no reserve, like no capacity for an air tank, it's going to use up all the air and it's going to slow everything down. The plenum also acts kind of like
the tank in your air compressor. It's holding a certain amount of air so they can feed it in the runners as it needs to be. So you need a certain amount of plenum volume for RPM. At lower RPM, clearly you don't need as much plenum volume. So having these in doesn't really hurt things. But as engine RPM increases, or you have a bigger cubic inch that requires more air, it needs more air, and these are hence blocking that path. So, and well, I guess what I'm trying to say is these will probably hurt your high-end power, but helps low-speed power. So that's why the Cloverleafs are there. However, the reason why I port most of them out is because 90% of the people that would ever buy a Dominator or intake manifold are using them for race purposes, which means they're going to spend more time at a higher engine RPM speed. So they don't need these in here. So we cut them out. And then I port them, because those guys are going to be like, they'll have a 5500 stall converter, and maybe they shift to 7500 RPM. Cutting this out and porting it, I'm almost positive you're going to run faster on the track. Now, if you're going down the street, it would probably feel more sluggish. You probably lost some bottom end torque, say at 2500 and 3500 RPM. But race cars don't care, because that's not where they operate. I'm sure someone would say, oh, yes, they do. Someone's leaving foot brake at 3500 RPM. Well, you're probably getting beat by someone who's leaving off 5500 RPM, where the engine likes to operate best. But anyway, that's one thing. The other thing is, a lot of people run nitrous, so, which is fine, or even turbocharged. We'll get to that in a second too. If you have a nitrous steel, you have a spray bar that goes across here. I mean to tell you, there's no spray bar that's just that width. Sorry, it isn't, because each one of the manifolds have a different length as far as where the Cloverleaf sinks in. So you have the spray bar that goes across here, and when you got fuel and air, fuel and nitrous coming out, hits this part and can't spread out right. So you might have a few cylinders that aren't getting as much nitrous or fuel as the others. You know what that means? Burn pistons. So cutting these out is almost guaranteed to have to happen for nitrous. If you're a turbocharged deal, maybe you got a forward-facing bonnet going like this or something, and you're feeding it in, you got one big old round opening. You don't even have the barrels like this maybe on some of them. So that means it's got to be cut out too. But let's say you do have a 4-barrel one. Well, that if it's a curved one in, you're still going to have some barrels that have different. So typically, on especially, and this is another thing for me, this is my experience. Excuse me. Anytime there's a nitrous engine, if I could, and this is from my experience from things I've done before and tests with customers, anytime I can make the plenum bigger by cutting these out or adding a spacer, typically the motor runs faster on nitrous, because now it has more volume here, what's holding more nitrous, so whenever you're putting it to it, it has more there. It just runs faster. The same thing could be said for turbos. Typically when I've made the plenum bigger, it holds more volume, so when the engine speeds increase, it's there. It's not limited because of it. So that's from my experience, from what I've seen and sold to customers. Typically they run faster with the bigger plenum, but I always cut out the Cloverleaf for them anyway. But even if you doubt that, if you got hood clearance, put a 1-inch spacer on your nitrous plate and see if you didn't go faster on the same nitrous jet. So typically plenum volume makes more power, at least in my experience, on nitrous and even on turbo deals. So cutting those out, have to do it anyway, but the cutting vision away. Engine at a higher RPM speed also needs that as well, and bigger ones. So being that this is a Ford manifold, of course they can make Ford engines are much bigger, so kind of what happens. Now, I want to give you some information on why I feel this way and things that I've tested and why I feel that the Cloverleaf is this way. Well, let me take you over this other manifold. Excuse the floor. Here. Now this manifold is a Dart small block Chevy manifold, and this is the one I used in 2012 Engine Master Challenge with a small block Chevy and a 400. I know some of you aren't familiar with the Engine Master Challenge because you're just used to the TV station or channel, but they used to have a competition, and the way that the 2012 one worked was you were scored from 2500 to 6500 RPM, your average torque and average horsepower. So say at 2500 RPM, they would take your torque and your horsepower, add them together, divide it by your cubic inch, and that became your score, but it was for 2500 all the way up to 6500 RPM. So in other words, if you had peak power of 700 horsepower, say at 6500 RPM, but you only had 300 foot-pounds of torque at 2500 RPM, you lost, and you lost bad. So having big peak power meant nothing, because there was a lot of guys that had really good peak numbers but didn't have near the torque down low, and they scored bad. So this was the best engine I'd done at it, and I finished 6th with the one that had this on there. This was a 406 with 11.5 to 1 compression ratio, 650 on lift on the camshaft, 244 duration, 750 carburetor. At 2,500 RPM, it had 477 foot-pounds of torque. Peak torque occurred at 5,200 RPM at 577, and it made 616 horsepower. So, and remember, peak horsepower didn't make a difference, because in those times, if you wanted to win, you want to score well on the Engine Masters, you could care less what it did for peak power. You focus down low, because your peak powers only occur like 6,000, 6,500. That's 500. Remember, you're scoring from 2,500 to 6,500 RPM. So you worry about the low speed stuff. Hence this. And this is the reason why I believe about the Cloverleaf. If you noticed, I added epoxy all through here to create the Cloverleaf, because a dart is one of the rare examples where it doesn't have one. You can kind of see the aluminum. It's not built in. I also added a turtle down at the bottom out of epoxy. The reason for this is because I was looking for any dead areas when I was using this on a flow bench. This was on and off several times. If it was dead, which means I could fill it in with modeling clay and it didn't affect flow, or flow went up, I added it. This is what it came up with. So in a high RPM deal, like I said, I think these are going to be in the way and it wouldn't run as good. But down low, it for sure helped, because it made the air as soon as it left the carburetor, it was the most efficient path down at the low speed stuff, and it worked really well. So everything where there was any dead air was filled in. So, but the engine itself, you could tell also though, once it hits its peak horsepower, it started falling off almost like a rock. Not that it had valve float, but nothing was geared for the higher RPM. That's the reason why I believe about the Cloverleaf. However, I would really like for Richard Holdner and I to get together to do a project so we can actually test that theory to make sure that it's true on an actual dyno. Because I've never had a customer come up to me and go, hey, could you port the manifold with the Cloverleaf in first, we'll dyno it, and then can you remove the Cloverleaf and we'll dyno it again, see what happens? They just don't do that. They're usually like, I need this manifold ported and I'm going to run it drag racing this 55 to 7,500 RPM, try to make 700 horsepower. Okay, guess what? The Cloverleaf's going to be gone. But anyway, hopefully that answers some of the questions about the Cloverleaf. But I do want to say one more thing, because let's go back to this. Floor. One of the questions you might be asking, because I get asked, is why did the manufacturers ever put this in here then? Why do they have the Cloverleaf? Well, it's typically to save the customers from themselves. They know that somebody's going to buy this manifold, and they're going to want to stick this one on a 351 Windsor that's only going to turn 6,500 RPM, hydraulic roller, and they're going to, if they had the Cloverleaf cut out, they'd be like, this thing's a turd. It doesn't accelerate well. It's not pulling fuel. It's horrible. And then the first thing they're going to blame, the customers rarely blame themselves for picking bad parts. They'll blame the manifold. Now, a lot of the manifold manufacturers know this to be true. So what they do is they kind of help yourself by putting this in here. So that's why I think a lot of them put it in there. Many manufacturers do a whole lot of things to help themselves not have as many calls about complaints, because customers are picking or doing the wrong things. That's why I think it's in here from the factory. So anyway, hopefully that helps you guys out with some stuff. I appreciate you watching. Remember, these are just my opinions. If you don't agree with them, there's probably other people that have different ones, so you can find those. You guys take care. I appreciate you watching. See ya.